Okay, approximately where we're picking up from yesterday. We were starting to talk about this as x approaches 4 from the right. Pick a value to the right of 4 and analyze the function. Okay? Because right now, if you put 4 in that, if you just put 4 in there, 4 in the denominator is going to give you a 0. So we need to figure out what's truly going on. When you do this, what? 7.0001 divided by 0.0001. I should have written a little smaller, but what are you getting when you divide that out?
70,000.
70,000 with this one? Something like that? Okay. What happens, do you think, if we add another 0? Huh? It's going to get bigger, in other words, right? So where are we going? Where's this limit heading towards? Positive infinity. Okay. So this is headed towards positive infinity. Now, there's a sign right there. I can place right there. I can fill it in. With that in mind, obviously, if you use just like 4.1, it's not going to be as big, is it? And so that's why the closer we can and use that 4.0001, it makes it more obvious to us. What about as 4 approaches from the left? Instead of using the 4 point whatever, we can use something along the lines of 3.9. So if I fill in 3.999, what do I need? 4 nines to make it equivalent to the other one. So at that point, what? I think that's what it would be. I don't know. What do we end up with here? A really, I'm going to say, quote, big number again. Except that this time this big number is negative. And so if it's a really big number that's negative, where are we tending towards this time? Negative infinity. Okay. So with that in mind, this is the one, gosh, I'm trying to remember from yesterday. Aha. So this is the one, if we jump back a page, I don't have the page filled in, but the graph is here, right? This is a graph we were looking at yesterday. As x approaches 4, if you look at the graph, can we tell that it's not going to be going to the same place? We've got positive infinity here, negative infinity here. The key is we don't always have a graph to look at, which is why I'm trying to make the connections here. So this is what it looks like on a graph. Numerically, we ended up with positive and negative infinity, yes? So as x approaches 4 in general, this limit will just not exist. But this is the way to analytically look at it, because we don't always have a graph to look at. And it's not always something you can easily graph. Okay? Questions on that? Kind of awkward because we stopped in the middle, and I was trying to remember where we left off at least. Okay, let's look at example 2. Excuse me. Finding limits analytically of piecewise functions. Show your algebraic steps. So, the limit as x approaches 1 of g of x, given that g of x is that following piecewise function. What do you notice about, it says x approaches 1, and what do you notice about 1? 1 is that break point, isn't it? So it's a piecewise function, meaning there's just two different pieces doing two totally different things possibly, but on one side it's one equation, on the other side it's the other equation. Well, if a limit exists, what has to be true? The limit from the left and the limit from the right have to be the same. They have to meet in the same place. And so that's where you're going to have to look at this individually. So if I start with looking at the limit as x approaches 1 from the right of g of x. So which piece of the equation am I plugging this into? If it's from the right, are we using x cubed plus 1 or x plus 1?
X cubed
Well, if we're going from the right, we want to look when values are x are greater than 1. Because we want to go to 1. So we're going to use x cubed plus 1. So if I plug that 1 in, it's going to be 1 cubed plus 1, which is 2. So the limit from the right is 2. Repeat the process with the left. The limit as x approaches 1 from the left of g of x. So this time, if we're approaching from the left, we want to look where x is less than 1. So this time we're going to plug in the 1 to x plus 1. So 1 plus 1, which is 2. What do we know? Huh?
Why are we plugging in?
Because it's the limit as x approaches 1. And the only reason we didn't use 4 here earlier is because when we plugged in 4, it gave me a denominator of 0. And so that's why we had to be a little more analytical about it and plug in a number really, 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 really close to 4. This one is just a general polynomial, so we can plug that number in. Okay? As long as it's just a regular, like x cubed plus 1, it's just a regular continuous graph. X plus 1, regular continuous graph. Does that answer that question then?
Yeah.
Okay. So, the limit from the left and the limit from the right are the same, yes? So a little bit of AP notation for you. I showed the limit from the right, yes? I showed the limit from the left. Now I need to show that they're equal to each other. So I can write the limit of x approaches, the limit as x approaches 1 from the right of g of x equals the limit as x approaches 1 from the left. So that is me. I showed what each of the limits was. I am specifically pointing out, saying, hey, okay, they are equal. Therefore, if they are equal, this is what we are trying to find. What is the limit as x approaches 1? It is 2. And so I can write, I mentioned those 3 dots that mean therefore. Therefore, the limit as x approaches 1 of g of x is equal to 2. And that would be good, solid AP notation. I know it seems like a little overkill, but that's what you have to do. You have to, this is what the one limit is, this is what the other limit is. I have to specifically say they are equal to each other. And then I can draw my final conclusion that, okay, that limit is 2. Okay. Can you handle the next one then? Limit as x approaches 2 of h of x. Well, it's a piecewise function. Not coincidence. It's as x approaches 2 and where's my piecewise function divided at? 2. That's not a coincidence, right? So, try both limits. The limit as x approaches 2 from the right of h of x. Which one am I plugging into for 2 from the right? The bottom one, where x is greater than 2. So I'm going to do the negative of 2 squared plus 4 times 2 minus 1. Does your answer match my answer?
Wait, why did we put the negative outside the parentheses?
Because that's what you do. Not a good answer, I know. Okay, so when it's negative x squared, that is saying the negative of whatever x is squared. So you're going to do 2 squared and then do the negative of it. As opposed to, like, if they wanted you to do that, they would have that. Okay?
Originally, that's what I kind of figured.
Right, yeah. And it's the difference of, when they say it like this, it's saying the negative of x squared. So it's the negative of whatever number you're squaring. Which, as you know, is different. Did you get negative 4? Did you get positive 4 here, right? Okay, did you do the limit from the left? The limit as x approaches 2 from the left of h of x. From the left, we're looking where x is less or equal to 2. So 2 squared minus 4 times 2 plus 7. So what do we know? Can we give the limit as h of x and limit as x approaches 2? Limit as x approaches 2 is going to be what? 3? Huh?
Bad math.
Oh, did you not get the 3?
I tried to do it in my head.
Which you are capable of doing. Which one did you mess up?
I don't know. Oh, there it is. 3.
Okay, so I'm going to state, since I showed that they're the same, I can't just state they're the same. I have to show they're the same, to show what they are first. Then the limit as x approaches 2 from the right is equal to the limit as x approaches 2 from the left. Therefore, the limit as x approaches 2 in general of h of x is equal to 3. Those are long in this lesson. Okay. Moving along. I think I was one behind on writing that out. Okay. Next page, we've already done a little bit of this. Talking about factor and canceling technique. Now, technically, there's a part of me that says we should always try direct substitution first. Meaning, when I say, okay, what is as x approaches -4? Plugging in -4 there, yes? And there's 50-50 shot. Okay, in this case, I think you end up with 0 over 0, if I'm not mistaken. Okay, which means, okay, we need to look for other options. An option that I almost always look for, I honestly do this a lot of times before I even substitute the number in directly, is I factor. Is I try and factor and see if that's going to help me any. So, let me rewrite the limit as x approaches -4. I always keep that limit sign with me. Okay, I'll factor the denominator. You guys factor the numerator? No? Huh?
Doesn't seem fair.
I was just seeing if you guys were paying attention here. Okay. We'll get the denominator out of the way. That's the easy one, right? X minus 5 and x plus 4? Or should I not say that out loud? Numerator. This is a decently easy one to try, guess, and check on. Okay. It's giving me the evil eye here. If you don't like my guess and check,
I'll do mine.
then do your product of AC. But this one, I say it's not bad because 2x squared. What must 2x squared break down into?
2x.
That's 2x and x. So I don't have choices for that one. Now, the 4 at the end, okay, I do have choices there, don't I? Because I can do 1 and 4, or I can do 2 and 2. Now, I can tell you it's not going to be 2 and 2. Because there was no GCF here in the beginning. And right there, if I put a 2 in this parenthesis, I'm going to have a GCF. But if there wasn't a GCF here, there can't be a GCF in either of these parentheses. Okay, now that's something I know as a math person. But so that means it's going to be 1 and 4. Well, again, I could kind of use the GCF thing to help me out here too. It's not going to be 4 here and 1 here, because that'd give me another GCF. So my guess is going to be 1 and 4. If it multiplies to be a -4, I need a positive and a negative. And then I have to figure out how to get 7 in the middle. So positive 7, these outsides are going to be 8x. And I'm going to need a positive 8x. So I'm going to put positive in front of the 4. And I'm going to need to subtract the 1x. So I'm going to put a minus in front of the 1. I don't know. If you still don't like when I do that, product of AC, right? Megan's with me. She's got her product of AC going. Now, the other thing is, could you maybe have guessed that one of these was going to be x plus 4 once you started looking? You know, like something's got to match up and cancel most likely. So, now, we are officially doing the limit as x approaches -4 of 2x minus 1 or x minus 5. Can we plug the value in now and try again? if we're going to plug the negative 4 in, as long as it's not going to give me 0 over 0 or infinity over infinity or 0 in the denominator, we should be okay. So I'm going to say 2 times negative 4 minus 1 over negative 4 minus 5. And that agrees with my answer key. Okay. B. I'm trying to remember, I feel like this is always the beginning of the calc book. I have to teach this. X cubed minus 27. Did we factor that last year? Maybe, maybe not. I feel like maybe we did. I don't know. I'm going to give you a little cheat sheet over here. In order to factor something in the form a cubed minus b cubed, okay? It factors into the binomial a minus b and the trinomial a squared plus ab plus b squared. Does that look at all familiar or no?
Yeah.
I'm not saying you remember how to do it. I'm just, maybe. You guys aren't totally shooting me down. I'm also, while we're here, going to go ahead and write out a cubed plus b cubed. It just has 2 sign changes in it. A cubed plus b cubed factors into a plus b. And a squared minus ab plus b squared. You have to know how to factor those. Do they happen a lot? No, but we need to know how to factor. So, the limit as x approaches 3. Well, let's see. Let me get that denominator out of the way first again. I'm trying to factor these. X squared plus x minus 12 factors into that, I think. I wrote down x plus 4x minus 3. Okay, numerator. Are you ready? This is of the form a cubed minus b cubed because it is x to the third minus, what do we know about 27? Three to the third, yes? So the idea that in this formula, every place I see an A is now going to become the x. Every place I see a B, I'm going to put in a 3. So if I think x cubed minus 27, the cube roots are my a and b values. So x and 3. So first parenthesis is going to be a minus b. So basically your cube roots, keeping the sign the same. So x minus 3. My other parenthesis is a trinomial. The first cube root and square it. So take x and square it, x squared. The middle term is my 2 cube roots multiplied together, opposite of the original middle sign. So my original middle sign was minus. We're going to say plus. My cube roots were 3 and x, so plus 3x. And then plus my other cube root squared. So 3 squared is 9. Was this beneficial? Certainly was. You can rewrite the limit out if you want, but the next step, the idea is to plug in the 3. We factored, we canceled. We should hopefully be able to work with this. So 3 squared plus 3 times 3 plus 9 over 3 plus 4. (27/7) maybe? Are we okay with that factoring I just did? I didn't totally leave anyone behind, did I? So you have in your notes now the forms there, so you can use those. Okay. Questions there? Okay. The bottom two. The bottom two look lovely, aren't they? Or don't they? No? You don't like the fractions? Okay, so, and again, right now, if we plug this in, if we plug 0 in, you can do a quick assessment. We're going to get 0 over 0. Is that what I want? No, we don't want 0 over 0, so we're going to try a different option. And we're going to get rid of those fractions. So look at all of the denominators and come up with our least common multiple. What denominators do we have? We have a 4, and we have an x minus 4. So the least common denominator between those is 4 times x minus 4, if you recall. When it's different factors, you just multiply them together. So what we're going to do here, I'm debating how I can write this out so I have room, is we're going to multiply my fraction here by that least common multiple on bottom and on top. So I'm going to multiply the top by 4 times x minus 4, and I'm going to multiply the denominator by 4 times x minus 4. I'm going to rewrite this out as the limit as x approaches 0. Okay, the numerator, don't make it harder than what it is. If I'm multiplying x times 4 times x minus 4, I would just put it in a nice neat form. You're just multiplying all those pieces together. So when I rewrite this, I would write it as 4x, parentheses x minus 4. In other words, I would put those single pieces together out front. So 4x times x minus 4. Now, denominator. How confident are we here? Okay, we're multiplying 4x minus 4 by both of these fractions, right? When you multiply 1 over 4 times 4x minus 4, realize the what? 4 cancel, and you're left with x minus 4 is what represents the first fraction. Plus, now in the second fraction, again, I'm multiplying 4 to x minus 4, this time by 1 over x minus 4. So this time, x minus 4 cancels with x minus 4, and I'm left with the 1 on top times that 4. Are we okay with that? I would not worry about cleaning up the top in terms of multiplying out or anything. Actually, now that I think about it, I definitely wouldn't. But we do need to clean up the bottom. So the limit as x approaches 0 of 4x, x minus 4, over, what's the denominator? X. All right, now if we plug it in, we're still going to get 0 over 0. However, do you see what can cancel? There's a factor of x that can cancel, right? Because on top, it's 4 times x minus 4. So we can cancel a 4, an x, or an x minus 4. So we're going to cancel the x. If I cancel the x, it is the limit as x approaches 0 of 4 times x minus 4. And now at this point, we should be able to successfully plug in 0. Okay, maybe?
So we don't have to put like limit of x.
Oh, for your final answer? Not necessarily, no. I mean, if you're showing the steps here.
So what's the difference between like answering it like with just the number and then like all this there?
Well, on that one, like this one, we're able to cancel and just plug the value in. On the one with the therefore back over here, we had to plug it in for the left, we had to plug it in on the right, and then we had to state that they were the same. So there was just a little bit more. It wasn't just finding a basic limit, it was a limit that was two different pieces. Does that make sense? Okay. If you plug in 0 right now in B, guess what? We're going to get 0. Yeah, 0 over 0. So, thoughts on what we're doing? Okay, multiply the top and bottom by 2 times x plus 2. Because we are trying to get rid of fractions within fractions, right? So, the limit as x approaches 0. Okay, on top. If you're okay last time, cancel, you should be okay this time. But with the first fraction, it's 2 plus x. I wrote x plus 2. Doesn't matter. No. So, but the x plus 2 is canceled, leaving us with 1 times 2, or in other words, 2, minus the next fraction. 2's cancel, and I'm left with x plus 2. Now notice it's subtracting, right? So I'm going to say minus x plus 2, but I'm going to put that x plus 2 in parentheses. Or I'm going to go ahead and subtract right off the bat. Okay? Denominator. Do you know what to write this time? When we multiply x and the 2 and the x plus 2?
2x,
I would write as 2x, x plus 2. Okay? So, if we clean that up a little bit, the limit as x approaches 0. On top, 2 minus x plus 2. Do you realize what's happening? 2 and this minus 2 will cancel, and we're going to be left with negative x over 2x, x plus 2. Again, like the last one, the x's can cancel, except what still remains on top you can't lose. There's still a negative, correct? So the limit as x approaches 0, I'm just going to put negative 1 over 2 times x plus 2. So negative 1 over 2 times 0 plus 2. Negative 1/4, I believe. Yes.
So on the first step, I noticed on the first step. Yeah, the first one, when you're canceling out, you, like on the one side it's x minus 4 plus 4 in the denominator, and then the numerator was 2 and then minus. So like, why don't you, I know you put it in parentheses for the sake of that subtraction, but why do you, like, is this one of the cases where they're not like attached together and you have to use them? So that's why you're able to do like the x and then put the x in the denominator because the minus 4 plus 4 canceled out, and then the 2 and then the minus 2 canceled out. Is that? It's like, I know there was some instances where it's like you can't do anything because they're together. Like,
Well, we can cancel factors. We can cancel things that are being multiplied. But we can't cancel pieces that are being added or subtracted.
Or is that added and subtracted?
So,
Because the x is being, the 4 is being subtracted from the x. So why is that able to be separated?
okay, so are you looking right here?
Yeah, right there in the denominator.
So x minus 4 plus 4.
Yeah, why is the minus 4 and the x able to be?
Okay, so that right there, that's just 3 things being added and subtracted. So it's x, minusing 4, adding 4. And so then when I look at like terms, minus 4 plus 4 will be 0. And I'm left with x.
Okay, so even though it's something that, like, because the 4 canceled the 4 in the denominator, that's why the 4 drops down to, like, so the x and the minus 4 were never, like, together. That was just something that came.
They were together, but you can still add and subtract other things to them. Like, so over here you question my parentheses. Yeah. I put parentheses here because when I rewrite this out, this is 2 minus x minus 2.
Yeah.
And so that's why I wrote it out that way. But it's still just 3 terms being added and subtracted.
Well, I get that it's the 3 terms. I just want to know why the x minus 4 and the x plus 2, why we can separate those, but you can't do it in other cases. Because, like, I thought it was, because I know addition and subtraction you can't do anything about, but those were added and subtracted, so why?
Are you talking about, like, when we cancel stuff?
No. I'll see you after class, I guess. There was something that
I know, and I'm trying to figure out exactly what you're talking about. The only thing I can come up with is when we cancel stuff, like we can cancel factors. I'm trying to come up with a good example, and I can't. But we can cancel factors, but we can't cancel, like, for instance, I don't know if this is, helpful or not in this situation. Or is this not at all related? No? Okay. Because this is the only place my brain's going, so I'm not following where you're at. Because what you cannot say 3 cancels with 3 here, because this is x plus 3.
Yeah, that's more
right. Okay. So that's not where you're trying to go, though. Okay. I'm not sure where you're trying to go.
Packet last year.
Okay. Yeah, I'm not sure where you're. It's not clicking with what you're trying to say.
Yeah.
So yeah, check in with me. Let's figure it out. But I'm not there right now. Or find me an example. Okay. Our other method, rationalization. Okay, our conjugate method. These are, how to use conjugate and to rationalize. We're going to use this when we have radicals, and specifically it's radicals, like in this case, add or subtracted to other things. This is a way to get it in a different form, because it's not like we can factor this one. Now, the graph is shown at the right of this one, and I think they're just showing the graph kind of as a proof of why the answer, why the answer is going to match up. But right now, I'm assuming, let's see, what's going to happen if I plug in -1? Oh, guess what? Surprise, surprise, we're going to have 0 over 0. So, when we talk about rationalization or conjugate, wherever your radical is, we're going to multiply by the conjugate of that entire either numerator or denominator. So, the conjugate of my numerator here, the conjugate of square root of x plus 2 minus 1 is going to be, do you know? Right, square root of x plus 2 plus 1. What we do to the numerator, we do to the denominator. So the limit as x approaches -1. Now, on top, how are we multiplying those? We need to, what? FOIL, right? And I'll be honest, on bottom, we're not going to multiply it out. But top, where the conjugates are, we're going to FOIL. What's square root of x plus 2 times square root of x plus 2? X plus 2. What happens to the insides and outsides when you're FOILing conjugates? They cancel. And so then what takes us to last? What's -1 times 1? -1. Okay, so my outsides and insides, you can write them out if you want, but they're going to cancel. That's the idea of conjugates. In the denominator, I wouldn't multiply that ugly thing out. Okay? I would just keep it as x plus 1 times square root of x plus 2 plus 1. And so the little bit of cleanup I can do is in the numerator. Limit as x approaches -1 of 2 minus 1. So x plus 1. Denominator, x plus 1. And square root of x plus 2 plus 1. Do you see it? We created something that cancels, didn't we? So x plus 1 cancels with x plus 1. I'm going to write my limit one more time, I guess. The limit, as x approaches negative 1 of, if all else fails, there's nothing on top, 1, or square root of x plus 2 plus 1. And now you should be able to solve your limit using direct substitution. Square root of negative 1 plus 2, so square root of 1 is 1 plus 1 is 2. That's your analytical way. Okay, when you don't have a graph to look at, that's your analytical way. Now, does that match with the graph answer? It was the limit as x approaches negative 1. So limit as x approaches negative 1 means you want to go from the left to the right. Does that look like it's approximately 1/2? Certainly does. Okay, so let's practice on B. With B, it's the limit as x approaches 5. Again, you're going to get 0 over 0 right now, or most likely. What are we going to multiply by? 3 plus the square root of x plus 4. What you do to the denominator, we're going to do to the numerator. So the limit as x approaches 5, that numerator, just leave it as is. Okay, we're not going to multiply that out, so we're just going to have x minus 5 times 3 plus square root of x plus 4. Denominator, you're foiling, yes? 3 times 3 is 9. When you do your outsides and your insides, they would cancel. Minus square root of x plus 4 times positive square root of x plus 4. It's going to be minus the quantity x plus 4. So, because it's going to be a minus of that term x plus 4, so it's going to end up minus x and minus 4. So, limit as x approaches 5. On top I had x minus 5 and 3 plus square root of x plus 4. My denominator cleans up to be I wrote negative x plus 5, or you could write 5 minus x. Are we in agreement one way or the other? Because it's 9, you're subtracting the x plus 4, so it's a minus x and a minus 4. Now, we're supposed to be able to cancel something right here. What's the deal, though? Yeah, it's not quite the same, but it's different by a negative. Do you remember how this works? Yeah. Think about this as pulling a negative out. So if you pull a negative out here, negative x plus 5 becomes x minus 5. And now, what can you cancel? You can cancel an x minus 5, and there's just a negative still lingering around. That is a technique you have to watch out for, is when you have factors just different by a negative, that you cancel the factor and leave a negative in its place. So I'm actually, when I rewrite this limit as x approaches 5, my only denominator is a negative 1, correct? I'm not going to leave that in the denominator. I don't know, I'm not going to leave a fraction unnecessarily. So I'm going to write it as negative, like -1, just writing negative, times 3 plus square root of x plus 4. If you'd rather leave it as divided by -1, it's equivalent. I don't care. And we're going to plug the 5 in. Five plus 4 is 9. The square root of 9 is 3. Plus the other 3 is 6. The negative of all that is -6. Okay. Sorry, I'm saying how to myself. I really thought I could get through all this today, but man, there's a lot. Okay. So we got another technique, right? Conjugates. You'll see conjugates in homework. You'll see the fractions from the other page in homework. Okay, 6. Let's see. 6, it's find each of them analytically. So a lot of times we think about that as just plugging the value in. On A, we can just plug it in, can't we? Let's try it. If we go to plug this in, we're plugging in 3, right? 5 times 3 plus 1. But what does the power of 2/3 mean? We have to understand what the power of 2/3 means. Okay, the 3 is the cube root, yes. And the squared is, you can square it now, you can square it later. I don't care. So in other words, you can say square of all of this, or you can put the squared on the 5 times 3 plus 1. There's a cube root and there's a square. So 5 times 3 is 15, plus 1 is 16. So it's a cube root of 16 squared. So interesting enough, I have written in my notes that technically you could stop here. That is a numerical answer, isn't it? Okay, that is a numerical answer. Maybe not simplified, but it is a numerical answer. Now, if we wanted to go a little farther, any perfect cubes in 16 we could pull out? There's an 8, yes? The cube root of 8 is 2. So it's 2 cube root of 2, and then still square. If you square that, then you're squaring both of the pieces. So the 2 out front, when you square the 2 out front, is going to become 4. When you square the 2 that's under the radical, it's going to become the cube root of 4. B. What's your step? By what? Use our rationalization or conjugate method. So we are going to multiply, which is where you were headed. Multiply by square root of x plus 1 plus 2. Square root of x plus 1 plus 2. Can I leave you a final answer and let you look at it later? And I say that because what is B just like? Is B just like these other two we just worked on? Or am I assuming too much if I say stop there and let you guys figure it out? Let's look at some of these others real quick. Okay. As I look, I'm feeling like this A through F here is really a lot of, we've tried something like this, we've tried something like this. You know, it's putting them more all together. I'm trying to remember what all's in the homework, and I don't remember off the top of my head. I want to take a moment and look at squeeze theorem with you. Do I have a moment to do that? I want to take a moment and look at squeeze theorem, and we'll see. I may come back and look at some of those other limits later. I'm not sure. Okay? We'll see as I need to look at those. No, probably. I want a moment. Squeeze theorem. That's where I want to go for right now, okay? I probably need to go back to this limits, but I may do that tomorrow. Squeeze theorem. The squeeze theorem, okay, that's one of our theorems in calculus. We have a lot of theorems, okay? Squeeze theorem is a technique used to confirm the limit of a function by comparison with two other functions whose limits are known or easily computed. Consider some function f of x is trapped between two functions on an interval containing a point. And so the idea is that if there is a function that goes between two functions at a point, and we know the limit of the other two functions, then we know the limit of that third function if they're right there in between. Okay, and so it's the idea right here that if we don't, you know, we can see what h of x is doing here, right? Okay, if we're trying to converge on that piece right there, we're trying to find the limit at c, we know it's going to be equal to whatever this L is. Same thing for F, yes? The idea is that G, because G goes in between those two, its limit at that point has to be in between the other two limits. Now, in this particular case, the limits are all the same. Okay? So, let me see. What this is saying here, okay, this picture does not go with A. That's what's confusing me here.
Is there like a typo in the? It says f of x is trapped between two. But wouldn't that be g of x is trapped? Or am I just?
Well, yeah, based on the way this is, g of x is the middle one. So, yeah, I don't know if she meant that to be g of x or if they were just saying in general some function. But based on keeping the paragraph consistent, then g of x, it should say g of x right there.
I was kind of throwing.
No, I see what you're saying. If we're trying to keep the paragraph consistent, because it would seem weird that she just, yeah. Okay. So, this example right here tells us that the function f is between the function of 1, which is just y equals 1, and the function of y equals x squared plus 2x plus 2. Find the limit as x approaches 1 of f of x. So we need to find the limit of the two pieces on either side. So the limit as x approaches negative 1, and we're going to use this one, of 1. Because right now we know is f of x is between these two functions. So that means the limit of f of x is between the limits of those two functions. Okay? So what's the limit as x approaches negative 1 of 1? You remember that rule? Limit of a constant is just a constant. Doesn't matter what it's approaching. The y value is always 1 there. And now we're going to do the other limit. The limit as x approaches negative 1 of x squared plus 2x plus 2. Do some fancy math there. And I already messed up the math in my head, so I guess I'm writing it out. I just totally got the wrong answer in my head. 1 minus 2 plus 2 is going to be 1. Do you agree with those two limits? So the idea now is f is between those two limits. But those two limits are the same, right? So what is the limit at f at that point? It's the same. It's that 1. Okay, so what we can say is, since basically these two limits equal each other, the limit as x approaches gosh darn it, not in the mood. As x approaches negative 1 of 1 equals the limit as x approaches negative 1 of x squared plus 2x plus 2, since those limits are equal to each other. And we could even say, and they equal 1, then by squeeze theorem, so we need to name our theorem here, by the squeeze theorem, we can now say the limit as x approaches negative 1 of f of x is also 1. Again, that's going back to the AP notation. Being able to put it into the appropriate jargon, so to speak. Okay. The squeeze theorem on the next, there's one more squeeze theorem on the next page, and it's a little bit of a different example. We definitely don't have time to go through that. Okay. What I'm going to say here at this point, I don't know, I guess I do have like a minute left or so, but my plan was to finish lesson 1-4 notes today. We're mostly done, right? Well, I think what I'm going to have you do is do the lesson 1-4 homework tonight, see where we're at. We'll check homework tomorrow, okay? Now, it may mean that we're not quite ready to check when we walk in. We may be ready to check when we walk in. I don't know, okay? And then my plan, if you look at your notes, the next section is just a review page, with the idea that then that leads us to a quiz. So if this can all work out, this is my brain saying, lesson 1-4 homework due tomorrow. You'll have we can work on it in class, talk about it or whatever, but the limits and continuity review it's there, right? If you have time to work on it, you want to work on that too, go for it. And then quiz Thursday is what I'm thinking. I do have the quiz review that's in there. I do have that answer key posted on the Schoology. So just like previous classes you've had me for, I did post the answer key there. Okay. Are we clear on what we're all talking about today? Okay. We'll see how much this backfires by me not doing these 4. I don't know. It may or may not backfire on me. Let me know tomorrow, okay?